because the coefficient of the x squared term is 1. That's the reason. Okay. I think it's really important for you to understand here that what we're doing today will only work if the coefficient of the quadratic term is 1. So, as a warm-up, we're asked to factor this polynomial. Now, when you were in grade 9 and you were, I guess, beginning to be introduced to the concept of factoring, and then you got to grade 10, your teachers probably said many times, factoring is very important. You need to know how to factor. And what I will tell you right now is it's the most fundamental skill moving forward in math in high school. If you cannot factor, you cannot be successful in Math 20-1. There's no way you could be successful in 30-1 or in calculus. It's a fundamental skill. So when we factor a polynomial of the form 1x squared plus bx plus c, you learn there's a rule. And that's that if this is factorable, it factors into two binomials. This is a trinomial. And these are going to be binomials. This will be a binomial, and this will be a binomial. And the idea is that when you multiply these two binomials together, you have to get this trinomial. What factoring is the reverse of multiplication. You're finding out what things would multiply to give what you start off with. And there's a trick here, and it's that if I asked you to multiply out these binomials, you would use FOIL. And if you used FOIL, first, outer, inner, last, if this is an x and this is an x, then your first will be x squared, which is what we want. So whenever you're factoring a trinomial that has one x squared at the beginning, it's going to factor into two binomials that have x and x in the beginning. Now, whatever numbers we put here and here have to multiply to give the negative 10. Let me give you an illustration that you're not going to write down because it's not even close to being correct. If I had x plus 6 and x plus 2, and that's not correct, you're not writing this down. If I asked you to multiply out x plus 6 and x plus 2, do you agree you would get a 12 here? Sure. What would you get for your outer and inner? Well, your outer would be x times 2, which is 2x. Your inner would be 6 times x, which is 6x. So what you would get would be 8x in here. And we would end up with the following. And I just want to point out to you that these two numbers I put here multiply to give the 12, don't they? But they also add to give the 8. Because your middle term is the sum, add, it's the sum of your outer and inner products. And all I'm getting at here, let's go back to reality and what this question actually is the numbers that you put here and here have to be two numbers that multiply to give negative 10, but those same two numbers have to add to give negative 3. And that's what factoring is about in this lesson. If you want to factor x squared minus 3x minus 10, then you need to find two numbers that multiply to give negative 10 and add to give negative 3. And I've taught long enough to know that the division here between abilities in a classroom is huge. Some of you look at this and you go, well, it's obviously negative 5 and 2. And I see people nodding. And those are the numbers. Your goal here, I would say, is that you can do it that quickly. But I also recognize, so this is negative 5 and 2. The order in which I put them doesn't matter, and we'll finish this off in a second. But I can't spend too much class time explaining this every time we have something to factor. What I can do is say to you that since they're going to multiply to give negative 10, what you're really, I guess, doing is going through all of the different options in your head. I mean, there's shortcuts that you're going to take, and I'm just curious, how many of you understand you wouldn't consider 1 and 10 because they're too far apart to give us that 3 in the middle? What other numbers multiply to give 10? Well, 2 and 5. So 1 can be negative and 1 can be positive. And what I will tell you, this is one tip that I will give you, is you always want to consider numbers that are closer to each other in value than numbers that are further away. So if I had numbers that were multiplying to give 24, I wouldn't be looking at 1 times 24 or 2 times 12. I'd probably settle in on 6 and 4. Maybe 8 and 3, but more often than not, the numbers are closer. So what we do now is we say, do these numbers add? This is a multiplication sign, not an x. Do these numbers add to give negative 3? No. 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 Yes. And I don't know how I can teach this to you at this level without, doing a million examples over and over again, which is what you do in grade 10. Well, not a million. You get my drift. So this factors into x minus 5 times x plus 2. And we're done. That's part A. Let's take a look at part B. Solve this quadratic equation. The quadratic equation is x squared minus 3x minus 10 equals 0. When you look in part A, was that an equation in part A? No, because there was no equals to 0. All that was in part A, was the expression. So we want to solve this equation. Okay, wait a minute. How do we solve a quadratic equation? The only way you know how to solve it is to imagine that what we have going on here is y equals x squared minus 3x minus 10. So I'm going to give you a minute. I want you to graph that on your graphing calculator and find the x-intercepts. My mic's been off most of the time. If a times b gives you 0, if a is 0, it doesn't matter what b is. Like, think about that for a second. If a times b has to give you 0, if a is 0, then a times b will give you 0. Because if a is 0, that 0 times anything else is still going to give you 0. Okay. So, solve these quadratic equations using the method of factoring. We have to factor these. It's very important, everybody. I know that some of you are going to say, oh, I get it. I don't need to do this. I'm telling you, you need to show this. It has to be equal to 0. You cannot just write a couple sets of brackets and start getting into the answers. So we're going to put an x here and here because the first term is 1x squared. If it's not 1x squared, that's a different kettle of fish that we'll deal with when we get back from the spring break. Now what you have to do is find two numbers that multiply to give negative 27 and add to give 6. So we want two numbers that are going to multiply to get negative 27. These same two numbers have to add to get 6. And maybe where some students fall short here is they don't know their times table. They've been relying on their calculator so often that they don't know how to do this. And I'm not putting anybody on the spot, but if your first reaction is to go, 27 divided by 2. No, 2 doesn't divide into 27. 27 divided by 4. No, 27 doesn't divide by 4. If that's how you're trying to find numbers that multiply to give 27, you're going to be left in the dust here very shortly. You should know 27 is 1 times 27, 3 times 9. I guess that's it, right? So, you know, is there any way to combine the number 1 and 27 in such a way to get 6 in the middle by addition? Well, there's no way. They're 26 apart from each other. But when you look at 9 and you look at 3, they're 6 apart. So it makes sense that if the 9 is positive and the 3 is negative, they will add to give the 6. And that makes perfect sense because we want a negative 27 when we multiply. So they have to be opposite in sign. The bottom line is it's x plus 9, x minus 3. What I want you, everybody, doing for the time being at least, which means for at least this lesson leading into the beginning of the next lesson, is I want you now to write x plus 9 equals 0 and x minus 3 equals 0. So again, the idea is that if blue multiplied by green has to give you 0, then green can give you 0 or blue can give you 0. Each factor is set equal to 0 to solve the quadratic equation. By the way, I love this from an educational standpoint and a teaching standpoint because we've gone from a quadratic equation, which is math 20-1 and 20-2, to math 6 equations. I mean, the one on the right, you know, if somebody in a grade 3 class should be able to answer that question. Some number minus 3 gives you nothing. You had some Smarties and now you don't have any. How many were eaten? 3. Right? It's a very basic concept. And this is my philosophy in high school math. You turn things into simpler things. So you solve these. This is x equals negative 9. Now, I don't, you know, a grade 3 student wouldn't maybe understand negatives, but a smart one might. And x equals 3. Those are the two solutions. Right? Well, we're going to factor this. K, You're looking for two numbers that multiply to give 50 and add to give negative 15. Now there's tips and tricks here along the way. If the two numbers multiply to give a positive 50, but they're going to add to give some negative number, then they have to both be negative. If you want to get negatives out of it somehow, it has to be by adding the numbers together. So now you're looking for numbers that multiply to give 50 and add to give 15, basically, because you've taken care of the negatives. Oh, 5 and 10. So this is k minus 5, k minus 10. Look, I know that you should be able to, every one of you should be able to look at that and go, oh, k equals 5, k equals 10. But I want you writing these two linear equations as a habit. Because, again, these factors will get more complicated later. It won't always be obvious by looking at them what the value for the solution is. So we add 5 to both sides and get k equals 5. This is what's going on, but I would say at this level, because we're not in a grade 6 classroom, at this level, this is what you're doing to solve for the variable. And then over here, you're adding 10 to both sides, and we're getting k is equal to 10. And we're done. Any questions with A or B? All right, C, what are we going to do here? What's the first thing that needs to be done here that we didn't have to do in A or B? Thomas, do you know?
Rearrange that so that the 80 is on the left.
Right, so zero the equation. Rearrange it so the 80 is on the left with all the other stuff. With a quadratic equation, you got to have the quadratic term, which is x squared, the linear term, which is negative 16x, and the constant term, all joining forces on one side. So we've got x squared minus 16x minus 80 equals 0, and now we're ready to factor. By the way, not all quadratic expressions are factorable. All of the ones today are factorable. We won't worry about what to do if they're not. We need to find two numbers that multiply to give negative 80. And you can really see here, there's no work other than writing the factored form down. Multiply to give negative 80. So my thinking here is that one of these has to be positive and the other has to be negative. They have to multiply to give a negative. My thinking as well, if you look up here for a second, and I know some of you are still crunching these numbers in your head, is that of these two numbers, this one has to be a larger number, because when we add them, we end up with more negative than positive. So I need a bigger negative number than I have a positive number. You know, I would start by looking at 8 and 10. How many of you, hands up and down, have the numbers already? Okay. I would start by saying 8 and 10, and then I would go, well, no. I mean, it doesn't matter which is positive and which is negative. I'm not going to get negative 16 out of that by adding them together. So what else could I do? Well, this is just what I do. I could take these two numbers, and I could take the number on the left and double it, and the number on the right and cut it in half. They should still multiply to give 80 if I do that. So I didn't start off by purposefully knowing 16 times 5 is 80. I just said if 8 times 10 is 80, then double 8 and half of 10 would have to be 80 as well. But this is not going to add either, is it? To give us the 16. But if I double the 10, I get 20. And I cut the 8 in half, I get 4. This has potential. 4 times 20 is 80, that's for sure. And if the 20 is negative and the 4 is positive, they will add to give the negative 16. There's not 100 tricks, but there's lots of different number tricks that you kind of have to, reach into your toolbox and grab from time to time. So bottom line here is x plus 4 equals 0. X minus 20 equals 0. So x equals negative 4. x equals positive 20. These steps that I'm showing you, it's 4 steps really. Zero the equation, factor the equation, create 2 different simpler equations called linear equations, and solve those linear equations. I'm going to tell you at the end of this lesson that that's what I want to see for work for the time being. I know many of us do not need to do that. Okay. Negative p squared plus 27 equals 6p. I need to zero the equation. How many of you understand that what we are going to be doing here at some point is this? That's what we want to do, right? Well, p times p is p squared, not negative p squared. Never ever try to factor something that has a negative quadratic term. Instead of moving stuff to the left, I'm going to move stuff to the right where the p squared becomes positive. So I'm going to get 0 here. The p squared is added to both sides. We already have the 6p on that side, and then we're going to subtract the 27. Haven't we done this one already? Or very close. Maybe it was negative 6. Maybe it was positive. It was positive 6, eh? 2 numbers that multiply to give negative 27 and add to give positive 6 are 9 and negative 3. So p plus 9 is 0. P minus 3 is 0. That means p is equal to negative 9 and p is equal to positive 3. Capiche? Excellent. Whoa. Well, should we just go home? No, not yet. Let's zero the equation. So I have 7x squared. I'm going to subtract 56x. I'm going to add 49. This is equal to 0. Now keep something in mind. I have told you, I made a big deal of it at the beginning, and I had mic issues, and so I don't know if, that it was 1x squared, right? The quadratic term. This first term is called the quadratic term. The second term is called the linear term. This is called the constant term. I made a big deal out of the fact that what we're learning today only works if the coefficient of the quadratic term is 1. And when we look at this question, the quadratic term does not have a coefficient of 1. So what can we do? Yeah. Yes, but we're only going to factor out the 7. Your question is, can we divide by the 7? And the answer is yes. I'm going to come back to that and say, and explain to you why I don't want us doing that. Okay, there's a really picky reason, and I'm just looking forward in the course saying if you get used to dividing that number out, it might cause problems later. And you've heard me say the similar thing, that same thing for other similar situations, right? I'm always looking out for you in the future. So we're going to factor a 7 out. The thing that we notice is that 7 divides into 56 without remainder. 7 divides into 49 without remainder. We can get that 7 out of the way. We're going to leave it there and have x squared minus 8x plus 7. Now, could we divide both sides by 7 here? And since we have 0, when you divide 0 by 7, you would get 0. Could we do that? Could I go, well, let's just go x squared minus 56x plus 49, minus 8x plus 7 equals 0. Could we do that? Yes, we're allowed to. There's nothing wrong with it. I will tell you right now why I don't want you doing it. Because if I teach students that we should be doing this, then what I see them doing is the following. When you have a function, I see them doing that. And you can't if it's equal to y, because when you divide both sides by 7, you're not going to be left with y. You're left with y over 7. It's a little picky thing. I would prefer it if you left the 7 there. So now let's factor this. Oh, this one is so simple. Like and I'm not meaning to put anybody on the spot, but if it takes you any real length of time to find two numbers that multiply to give positive 7 and add to give negative 8, you don't understand the nature of positive and negative, because there's only two numbers that multiply to give 7, 1 and 7. So how can we get negative 8? Make them both negative. And again, I'm not meaning to not be helpful. If you need help with factoring, I'll help you, but this is very basic stuff. That means that x minus 1 equals 0 and x minus 7 equals 0. So we solve each of these and we get 1 and 7. Any questions with that one? Because there very often is a question that somebody wants to ask about this. The question that some people will ask, and it's a good one, what about this? Right? Like you're saying, well, we have to look at this and we have to look at this. Why don't we have to look at that? I'll ask you, why don't we have to look at that factor? Okay?
Because it doesn't affect the x-intercepts.
Right. It has no x in it. So if I said to you, what value of x makes this factor 0? If I say to you, what value of x makes this factor 0, there's an x in there that makes sense to talk about, right? Oh, 7. What value of x makes this factor 0? 1. You walk into the room and I say, everybody, what value of x makes that 0? I expect to get 27 strange looks from 27 different people, because it doesn't even make sense to ask that question. So that's the reason why. Let's take a look at the final one. This, I believe, is the final one, yes? Okay. So clearly everything must be divisible by 8, otherwise it wouldn't be in this lesson. You have to be able to factor that 8 out. If you can't, that's a different lesson. That's for when we get back from spring break. So I can factor the 8 out. I'm left with t squared minus 9t plus, oh boy, 8, 2. $13? $14? Sorry. It's been a long week. Plus 14. This is equal to 0. Another thing that's you might think it's very minor, but boy, it bothers me, is this. If I'm seeing that you've written that down and you're ready to go to the next line, you're missing the point, because it's equal to something. It's equal to 0. And again, this isn't just me, some kind of quirky thing that, oh, it bothers me. There's a mathematical reason in your learning for putting equals 0 there. Let's see. T, two numbers that multiply to give 14 and add to give negative 9. Another, what I would say, is an easy one. 14 in terms of products is either 1 times 14 or 2 times 7. 2 and 7 give us 9. So negative 2 and negative 7 give us negative 9. That's it. We're done. There really isn't much to this lesson. But given what we're going to be looking at factoring, everybody, just indulge me here for a second. Given what we are going to be factoring, and I'm not doing this to scare you, I'm doing it to motivate you. all of this stuff on the left, you're going to have to know how to factor. By the way, you can't factor out the common factor because there isn't a common factor. All of this stuff, look at this. You're going to have to know how to factor that. And I'm not trying to scare you, I'm trying to motivate you. That if you don't follow my directions as well as you can, the wheels are going to start falling off the car here soon. That you have to know how to factor. It's going to get highly algebraic. I guess this is the pinnacle. This is the peak of everything, is factoring stuff like this and factoring stuff like that. You have to understand the basics before we can get here. So don't take this lightly. I'd like you to turn the page, please, and look at the next page, and just tell me, how many questions do I have there? 32? 40? That's your homework. Because, and this isn't, oh, that's practice. That's your homework. And what you should find is, regardless of where you're at, as you do more and more, you will get quicker and quicker at it. And I don't want you doing it on that paper. There's not enough room. I don't want you taking shortcuts. I want you writing it in factored form equals 0, and then writing the two factors equal 0, showing all of these steps. This is the first time in this course where I've said that's homework, and that's how important it is. Okay? So get to work on that. I'll be around to help you out individually in just a second.